Hello and welcome to JavaScript Marathon, a full week of free online courses in some of the leading web development technologies and concepts. Happy to introduce Chris. I'm going to say your last name very slowly so I get it right. Trzesniewski. Did I do okay? Chris, welcome to JavaScript Marathon. We're happy to have you.
Hello, everyone. Nice to see you all.
Chris is going to be presenting Create Your Own GitHub Action with TypeScript. A special thanks to this week's sponsor, This.Labs, offering personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. If you find keeping up with constantly evolving technologies a struggle and want to bring your team up to the speed on one of the latest technologies, contact us today at hi@this.co to set up your complimentary needs assessment. We are still hiring. If you're a senior software engineer or developer advocate, send us your info at jobs@this.co or take a look at our open positions at this.co/jobs. We have a ton of upcoming events, starting with Women in Tech Monthly Mentoring tomorrow. React Mentoring kicks off next week, along with State of You on March 24th. And React World Tour makes a stop in New York City on April 5th in partnership with Real World React. JavaScript Marathon Week continues tomorrow with Building Your Own Style Framework with Vanilla Extract with Tom Van Antwerp. And March 17th on Thursday, we'll see Exploring Nux 3 and Composition API with Adesoji. JavaScript Marathon Week returns in May. We're releasing training in Node, Cloudflare, and more. Don't miss it. You can find out all the details at javascriptmarathon.com. And with that, I'm going to turn it over to Chris.
So hello, everyone, again, and welcome to this week's second JS Marathon presentation. I will be talking today about GitHub Actions. So let's start with introducing what GitHub Actions actually are. So GitHub Actions allow us to run scripts and automatically run jobs or workflows on a repository. And it can be kicked off by many different events like push to a branch or pull request update or issue creation and many more. And with the help of GitHub Actions, we can easily automate various processes. For example, linting and testing an application on each pull request, or building and deploying a project on every push to the main branch. And of course, many more. GitHub and its community provide us with multiple actions out of the box. So there is plenty we can do with those, but sometimes we want to automate a process that might be very specific to our project needs, or we are just automation lovers and we want to create our own automated action. So in this JavaScript Marathon, I will show you how to create your own action and get up and running with TypeScript. So without further ado, let's get into some coding. So as you might see on the screen, I created an almost empty repository for us to work with. Sarah will post the link to that. And to get started, we just need to clone it. So you can copy the git link from here and git clone the repository. I already did that, so I will just go into the directory, GitHub, and open code, VS Code. So we have it open here. So as you might see, this is an empty repository. So we need to initialize it with Node and TypeScript, etc. So let's start with initializing our repository with npm. It will ask us a bunch of questions. Let's answer them all. So for the entry point, since we are using TypeScript, it will be compiled into JavaScript. So I am using a folder to put the files in, so that's why we will point to index this/index.js instead of customary or like default index.js in the root directory. For the test comment, we won't do anything. Git repository is good. Keywords, author, not relevant at the moment. License, and if everything looks okay, we have our package.json created. Now we need to install all the necessary dependencies for TypeScript to work. So I will start with installing TypeScript and also some node types that will be useful for all the node libraries that we can use. Okay, and following that, we need to set up TypeScript tsconfig file, which we will use to let TypeScript know where the source files are and where should they be output. So let's create a tsconfig JSON file. And I've already created one. It's based on the recommended settings. I have a couple of additional things. In the full repository that I will share after, there is also testing setup, but we will skip that for now. So that's why we use separate files. So for the building, we will create yet another file called tsconfig build. And we will just extend the existing base tsconfig. Okay, so we are extending it, and we just point that we will compile TS files in the source directory, and we will exclude the test files. And here we actually, as I've mentioned earlier, we will output everything to this directory so that we have those files separate. Okay, and last setup step before we actually write some code is to create a build script in our package.json. So next to, or like even instead of our test script, we just use TypeScript compiler with a flag to point to type tsconfig file, and this is all we need to do. And now we are set up with TypeScript. The only thing we need to add is an actual source code. So let me create source directory, and inside of source directory, I will create index.ts file. And let's just like console log hello world. And we can clear. We can npm run build. Sorry, typing is hard. And as you might see, we get an index.js file in our this directory, which is practically the same, just we are explicitly using strict mode in here. So this is all we need to get up and running, but we all, since this is a Git repository, and it's a good practice to ignore all the generated files. So I will just create git ignore file, and let me find. Well, we need to ignore node modules as usual. We don't want to put every node modules in our Git repository. This folder shouldn't be in there, and some editor configuration. I use both IntelliJ and VS Code, so I will always put both of them. So this is the initial setup, and why do we have so many so much different here? Git status. This should be. Let's remove it for a moment. Probably because I added gitignore after installing, it was added to npm install. And I think the same happens for this folder. So something is off. Did I type git? Of course, I misspelled this file. Git ignore. Now. Hopefully now it will all just oh, and now the node modules are ignored as they should be. Okay, so we can commit that as setup TypeScript. Should be okay. Okay. So with TypeScript all set up, we need to actually also set up the GitHub action to work in the to be recognized as one. So for that, we have a configuration file which is called action.yml, which is a YAML file that similarly to package.json, which defines our node setup. Action YAML will define what our action is and some description and also the entry point. So in this case, I will add some metadata. Description. Custom GitHub action with TypeScript. So if you don't know YAML syntax, it is very similar. Like it is like JSON but stripped out of all the parentheses or like curly brackets, actually. So in this case, indentation is what specifies where to put where our property will end up. So we define a couple of basic metadata, and the next important part is similar to what we had in package.json, which is main. In this case, we were pointing to index/index.js. And in this case, we need to point to the same file, but we define that by defining rounds property, under which we define what we will use to run this action. In our case, it will be node 16. And what is the main entry point? In our case, this index.js. And if we deploy, if we build and deploy our action to, let's say, a separate branch or tagged commit in our repository, everyone should be able to point to our repository and use our action just like so. But it is easier to set it up all in one repository for testing. So we can set up our action just as we would do with any other out-of-the-box action. So we need to create a directory for all the GitHub related stuff, which is called .github. And inside of that directory, we need to create another one, which is called work. And this is where we can put as many workflows as we want to in the YAML format. So in our case, I will create test.YAML file. And let me actually copy and paste most of it. Test. Okay, so I will hide the terminal for now. So we need to define a name for that workflow. And then we must define what triggers will run this workflow. In our case, either a push to main or a pull request, any pull request that is created against main branch. And then we, within jobs property, we define an array or actually a map of jobs that we want to run. In our case, well, we can actually call it run action. And let's call it run action. So this is just a name that we will use to see what is running. This is important. We can run our GitHub action on multiple different targets. In this case, it's just Linux virtual machine that GitHub hosts for and manages for us. So every step that we execute will be executed on a separate virtual machine that will be cleaned up after we finish the workflow. And there are a couple of things that we need to do before we actually can run our action. In this case, we need to first check out our repository. This is the out-of-the-box GitHub action that GitHub provides. Then we also need to set up Node environment to actually run Node version to install Node version 16, and this is some caching for the npm install to not take too long. Then we actually need to install dependencies. npm CI is similar to npm install, but it will error if the package log is not up to date. And then we can build our action local, on the test on the workflow. And this is where we have everything that we have locally currently, and we can run our we can tell the GitHub runner to execute our action. So this is very similar to like every publicly available action. So we can add a name, run my action, and then instead of putting like a public name or like a global module, we can point to a directory inside of our repository. In this case, it's the current working directory, and GitHub runner will find the action YAML file in that directory and will be able to know what to run because we defined the this index.js as an entry point. So if I create a branch for that, git checkout branch feature setup action. Just so that we can see easier that pull request is triggering this action. So we can commit this setup action. Yes, publish branch. And we can go to our repository. We can see that setup action has been pushed. We can create a pull request. And after just a couple of seconds, it should start running it. Yep. We can see that the action is triggered. We can see the details. And all the steps that we defined in the test YAML file will be executed in here. So we can see that node is being set up, dependencies are installed, we build an application, and then we run our action. And in this case, this is not very impressive. We just print hello world. But this is a good start. We have our action running, and we can push more stuff to test what we can do. What we can do additionally. So let's get back to our code editor, and let's see what we can actually do. So GitHub provides us with two packages that are that will help us retrieve the information from the GitHub runner about the event that triggered the given action. And this is these are, let me paste. So actions core and actions GitHub. And that is the main two packages that we will need to actually do most of the GitHub related stuff in our actions. So let's install it. Pum, 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 pum. Of course, internet is slow, but bear with me. So up until now, we were printing just a static constant string, hello world. Let's see if we can actually make it more dynamic. So let's create a function called greet, and let's input as an input. Let's have a name and just console log. But instead of hello world, we would print hello name. But where do we get this name from? So this is where actions core will help us. So we can actually get some inputs from the user or from the GitHub runner. And to do so, there is a handy function called getInput, which is declared in actions core. So to get an input, let's say we want to get name, we can just const input name, get input name. And then we can just call our greet function with input name. Okay, so from the code perspective, this is all we need to do. But where does this name come from? So this is yet another thing that we can define in the action YAML file. So apart from like all the basic metadata and what do we need to run, we can also declare inputs in here. And we can name them. So in this case, we are expecting an input called name. And we need to provide some description. Name to greet. And we can tell if this value is required. Let's say it's not required, but since it's not required, let's provide a default value. JS marathon viewers. Okay, and for now, this is all we will do. So define and use input. And let's sync changes and see what happens. Bum, bum, bum. As you might see, we pushed our changes, and we need to wait for a couple of seconds for it to be triggered. And then we can view the details, and our action should print the input. after a couple of seconds. Okay, if we look at run my action. Hello, JS Marathon viewers. Nice to see you all. So as you might see, this is the default input. We didn't have to provide anything. But what if we want to actually provide a value? Then we can do that in the actual workflow definition. So similarly to, for example, as we do here, we define some parameters for like node version, some cache stuff. We can do the same with our action and then we can provide a name. And this is a smooth segue to our sponsor, this.labs. Thank you, this.labs, for sponsoring this JavaScript marathon. Let's see what happens if we thank our sponsor. It changes. So let's go back to our pull request. Wait a couple of seconds for it to update. Yeah, it runs. And let's see if our sponsor will be proud of us. Okay, building, running my action. Hello, this.labs. Thank you very much. Okay, so we've got inputs. We defined default values and we provided a custom value. But this is nothing impressive so far. How do we actually do something more? How do we retrieve some data from the GitHub and I don't know, like do something about it? So this is where the second library comes into play. We can actually let's close others. We can actually import some stuff out from there. Let's for now let's import actions GitHub. And what do we have available in there? Let's see. Since this is TypeScript, we can easily autocomplete. Okay, so we have a context. What is context? This is the object that will be provided for us by the action runner, and this will be all the basic data about the repository that we are running this against, and also the payload that is related to the trigger that trigger this action. And this is to actually learn more about it. You can view the documentation site, which Sarah will point the link to in a moment. And you can see that there's a lot of triggers that can run our action. But since we are, in this case, we are concerned about pull request, we can see what is available in this payload, and also see a small example payload. But let's see what our real payload is given our repository and action. So let's auto-format it. And okay, we can. This is just something I like to do to have more type safety. I just create a GitHub context type so that we can, for example, get the URL of the repository that we are currently running against. So let's create another function called function get repo URL. And let's pass a context into that. So let's GitHub context, and this should return a string. So how do we retrieve the data we need from the context? So let's see what context actually can provide us. if we do context dot, we can see what is available. And two things that are relevant to us is the repository and the server URL. So let's search for a repo. Okay, we've got repo, and you might see that this is an object that contains owner, which in this case it's my username, and repository, which is the name of the repository. So let's see what else do we have available. Context, and the second thing was server URL. And this is, for the most part, going to be just github.com. But if we run GitHub Enterprise, this might be our own custom server. So this might be useful to extract both of those. So let's just destructure them. Repo server URL. And let's return a string that will represent our repository, or like point to our repository. So first server URL, then slash, then repo.owner slash repo.repo. And then we can modify our grid function to actually take a repo URL string and let's print some information. You are running a GitHub action in repo URL. And since our signature changed, we need to actually provide something in here. So like get repo URL and our context. Okay, so now we will print some additional data. Let's push it, print, like retrieve repo data. Save changes. And this is a nice thing that we set up our action to run on pull request. We can easily like test it on the live environment over and over again. Retrieve, we should wait a moment, and then we have a queued action. Hello, this.labs, you are, oops, that disappeared. Hello, this.labs, maybe I should zoom in. Too much. You are running a GitHub action in github.com, ktrz, and the name of the repo. Okay, so we've got some metadata available in the context. Let's just quickly see what else we can get from there. I created a simple code snippet, like to show you. So we've got a bunch of stuff available directly under context, which will be available always. So like what event name triggered as, what is the current SHA of the commit, and like additional metadata. And of course, there is a payload object, which will differ depending on the action that triggered us. So let's quickly see print all payload. And having such an example payload is going to be useful, for example, if we wanted to do some unit testing of our action to actually mock the data that we will get. So it is useful to have such an example. And we can always, of course, use the one provided in the docs, but I think it's nicer to have our custom one. I see some questions are popping up. I will go back to them a bit later. Where is the action? show all checks. Okay, so we've got all the metadata in here and the payload. As you might see, there is a bunch of things that are available in here. But of course, this object has to be limited, so not every information can be included in here. So for a lot of use cases, this is enough for us to work with. But sometimes we need to retrieve more data from our repository to actually do something useful, let's say. And this is where the idea for this talk came from. So a couple of weeks ago, we were posting some tongue twisters from different languages in our Slack channel. And after going through a couple of them, I noticed that the ones from my native language, which is Polish, contain a lot of consonants compared to vowels. Like Polish language is just a lot of consonants that nobody can pronounce because they are like all bunched together, next to each other. So this gave me an idea of what if we created an action that will tell us what is the ratio of consonants to vowels in each of our pull requests. So we can easily do that with GitHub Actions and some additional information that we can gather from the repository we're working on. So how do we do that? How do we access, let's say, the diff between our current head commit and the target branch that our pull request is referencing? Since this is not included in the context, we need to get it from somewhere else, and this is where GitHub's API comes into play. Namely, we can use GitHub REST API, for example, but luckily we don't have to do that from scratch. The Actions /GitHub package provides us with the OctoKit client via a handy get OctoKit function. But there is one additional thing we will need for that to work, which is a GitHub token to actually authenticate our request. So how do we get that? Well, let's assume that it will be provided as via an input. Get input and GitHub token. And how do we actually pass this GitHub token to our action? We can do that well, let's first define it, just so that we don't get any warnings later on. GitHub token description, GitHub access. Okay. Required false. And we won't provide any default value because if there is no token provided, we will fall back to not doing anything, basically. So how do we pass this token to our action? Of course, we can we need to somehow put it into the with object as GitHub token, but where does it come from? So the nice thing about GitHub Actions is that it will generate a GitHub token for us and put it under secrets context variable, and we can access it in the YAML file via the interpolation syntax. So this is basically double curly brackets, and then we can access secrets GitHub _token. But as long as we don't if we don't want to share it with some GitHub Actions, we need to explicitly pass it to the GitHub Action for it to be available. So it's secure and only allowed for the actions that we explicitly pass it to. So let's see what we can do with that. We've got our get octokit. Let's see. Let's create another function. Get diff and so we need to actually check if we have a GitHub token. Because if not, well, it's if the repository is public, I think it's possible to request it. But if it's private, then we won't be able to. We would get an access denied error. So just for safety, let's verify that the token is provided to us, and then we can create our octokit client. Octokit get octokit GitHub token. Okay, and now we've got our client up and ready for use. So how do we get some data? So we've got two options. We can use GraphQL or REST API. For simplicity, we will use REST API in this example, and then we can access multiple endpoints. In this case, we are concerned about repos and compare commits. And we pass some options object into that. And this is where TypeScript is very handy. We can see at the error and see that we are missing repo, owner, base, and head properties. So let's quickly fill them in. So let's see again. Repo, owner, base, and head. Okay, so repo, this is easy. We've got it in the context. Repo. Owner, similarly, context, repo, owner. Head, well, this is where our payload comes in handy. We can actually get context, payload, pull request, and as you might see, this is optional. So if our workflow is not triggered by pull request, this will be empty. So it is good to verify that we actually have this available. So and now TypeScript will know in this case that we can access safely access some properties. And unfortunately, the type system for this pull request is not complete. So we just need to look at the output that we were given and see what is available there. But we've got base.sha in there, or actually head object, which contains a sha string, and the same for base. Copy. Base head base. And the REST API by default, I think, queries 10 entries. We can increase the page size by adding page parameter, and the maximum value, I think, is 100. So if we wanted to work with more than 100 files per pull request, which sometimes happens, but it's not a good practice, I guess, we would need to handle paging as well. But in here, we don't care about it so much. So we will just await this because this will return a promise. Const result. And this will be some kind of result. We will see what it is by using, actually we need to create this function as a thing. Okay, and then we can return something. So let's return result. Data seems reasonable, and then file seems that's something that might be useful. But files is again optional. So just in case it's not provided, let's fall back to an empty array and just here like return empty array if like no GitHub or payload is provided. And we can actually print it. Let's say here. Get diff, then files console log copy. So your PR diff is given like that, and to make it printed nicely, we can actually either like dedent it to the align it to the left, or we can use a handy package called dedent. Let's npm install dedent and npm install the oops dedent. And we can import dedent from dedent. And where did we need that here? We can dedent our message. So this is acting as a text template. If you don't know what that is, we could basically run it like that. I guess it would be simpler for understanding right now. So let's leave it like that. And print diff. So let me answer one question, because since we are waiting for it to execute, I see that John asked about some cool uses of GitHub Actions. So one of the projects I'm working on is GitHub Action for benchmarking, which allows you to run and run benchmarks and then track the benchmark data over time, and also allows you to visualize those. So this is like, for example, for some Rust benchmark, we have some historical data for that, and we can visualize that. And on every commit to main, you will get a new entry at the end, so that you can track if your code base is not regressing or it isn't like out of the blue, it's not twice as fast or something like that. It's very handy. If you are interested, I highly encourage you to check it out. There will be a link. I can maybe post it to Sarah. So I'll have a look. And oops, I see that there is some error in our GitHub action YAML while scanning. There is definitely some issue with. Okay, I forgot the the usual semicolon or colon or something like that is missing. Fix YAML action YAML. And I think we are running out of time, but I created the full repository with all the features that I intended to implement. The next one would be actually to, on every pull request, to add a comment on your pull request. Let me show you how it looks like. Post comment on PR. So on every pull request, you would get a consonant to vowels ratio. Your PR added this amount of consonants, this amount of vowels, and the ratio is like that. And I don't know, you could sprinkle some additional things on top of that, or like additional information, or you want your repository to use a lot of consonants because you you want it to be obfuscated and unreadable. So you could make a threshold of like 3, so that it's 3 times more consonants than vowels in your code base, and make your code less readable. Just for fun, of course. Don't do that on production. I think we can wrap up with the functionality like that. There is a lot of things you can do with GitHub Actions. The most important thing is, I guess, that if you can script it, you can GitHub Action it. So whatever you imagine that you could run in Node, in Bash, in actually Docker, because additionally to running Node.js actions, you can actually run any Docker container and use actually anything you want. But this goes out of the scope of this talk a lot. So do you have any questions that I could answer you? I think now it's a good time for Q&A.
Great. We answered John's question. Thank you, John, for asking that question. We'll give everyone a little bit more time to ask questions. I'm going to drop Chris's Twitter handle in the chat. So if you don't get a chance to ask a question, you can always follow up with him on Twitter. So you can find him there. We also have dropped some links for you along the way, and we're going to also put those in the description on this video so you can see those later. Let's see, another one. Here you go, Chris. In a GitHub action that calls an API, is there timeout?
There is you can define a timeout for the whole workflow, and I don't remember what the default one is. I think it's like an action cannot run more than 1 or 1.5 days or something like that. But I guess the default, I'm not sure what the timeout is for the specific API calls. I think this would be more specific to the GitHub OctoKit client rather than the GitHub action.
Great. And if you're watching this on playback, please feel free to reach out to Chris on Twitter. We've dropped his handle there. Chris, thank you so much for such a great training. I really enjoyed it. Tune in tomorrow, same time. Tom Van Antwerp will be here, and Thursday, Adesoji's doing a live session. We can't wait to see you. Thanks again for tuning in. We'll see you soon.
Thank you all.